Good morning students, welcome to our next video. So in the previous video we have seen the automation part, right? It's a basic example and it's some of the important benefits of automation in the today's world. Okay, so we have seen what is automation, right? Then we have seen some examples, modern examples of the automation: refrigerator, washing machine, industrial automation, robots. So these are the automatic robots. Then we have seen the all the branches which are the integration of the industrial automation, means mechanics, electromechanics, electronics, control, circuitry control, digital control system, computers, computer aided. Okay, these are the integration of industrial automation we have seen in the our previous video. Then we have seen the example like CNC machine, in which automatic tool changing uh, technique is used. So this is also an example of modern automation device. Then we have seen the benefits of automation like increased productivity, quality, flexibility, convertibility, and also reduces manpower, personal accident, cost of products, and etc. Okay, we have seen all these points in detail in the previous video. Now in this video we will look the types of automation. Okay, so basically the automations are categorized into three parts, like fixed automation, programmable automation, and flexible automation. Okay, so with the as the name it is written that it is a fixed automation, programmable automation, and flexible automation. Fixed automation means it can do a certain kind of production with fixed amount. Like programmable means it has a programmable feature, and flexible means it has both the features, right? So in detail we will see what is fixed automation, programmable automation, and flexible automation. Okay, so the first one is the fixed automation. Fixed automation. So if a process using a dedicated equipment to perform fixed and repetitive operation in order to produce high volume of similar products, means if I want to produce same product at a very larger quantity, then in that case with a dedicated equipment, then I will use the fixed automation technique there. Continuous flow and discrete mass production system uses this automation. Like continuous flow, if I want to continuously produce my the product, then I will use this kind of automation. Like the examples of fixed automations are conveyors and transfer line or transmission lines. Okay, so these are the examples of fixed automation. Initially it has high investment for equipment but high production rate. Means initially we have to invest large amount for the equipment, but after that the production rate will be automatically get increased. Then it is relatively inflexible in accommodating product variety. It is inflexible means if I want to change my process in between the running process, then it is not possible in case of fixed automation. Okay, I have to stop that particular process, then I have to manage another process at the same time. So this kind of process is automation is fixed automation. Okay, next one is the programmable automation. As the name suggests, it is a programmable. Then there is a need of a skilled operator. Okay, that skilled operator will be able to program and give higher level commands to each and every automation devices. So it is called as programmable automation. Means if I want to change the change the sequence of operation, then this kind of automation is preferred. Okay, so there is a control, means one operator or an engineer is needed, which will program in a control system which will be automatically controlled with the help of programmable automation. So if I want to enter a new program, then there to produce new product, then I will be able to do in the case of programmable automation. Okay, next one is the now next point is the it is used in low and medium volume of production. Means not very high amount of means large amount of product is not needed, then in that case programmable automation is preferred. But it can also be used for large quantity of production line. Okay, so it is called as programmable automation. Next one is the flexible automation. Okay, flexible automation, as the name suggests, it is a flexible, means there is need of one operator, okay, human operator, computer, okay, computer. With the help of computer only, the programmable will be programmer or an operator or an engineer will be able to program any certain process, do exchanges on that process. Okay, so there is a computer, okay, computer, human operator, which will give the higher level of commands, okay, to control any devices. Each production machine receives signals or instruction from the operator with the help of computer. Okay, automatically loading and unloading is done with certain changes in that particular program. Okay, in flexible automation also we can program. So there is no lost production time. Okay, if I want to, if I look the fixed automation, then I have to, if I want to change the product or if I want to add some product in the fixed automation, then it is not possible, right? If I want to change, then I have to develop some another system for this fixed automation. But in case of flexible automation, the operator only makes certain changes in that existing program, then automatically the new production of the product can be made easily. So the example is multi-purpose CNC, like as I have said that in CNC machine there is actually a automatic tool changer, which the automation of that tool changing is done by the operator with the help of programming through computers. Okay, so these are the automation types. Right. So now the next one is the different systems for industrial automation. Means these are the systems which are used in the industrial automation. Like the first one is the PLC, as we know, then it is a programmable logic controller. Basically it is a controller. Okay, next one is the human machine interface, that is HMI. Third one is the SCADA. Fourth one is the DCS, that is distributed control systems. And the last one is the drive. Okay, now we will see all these 5 points one by one in detail. So the first one is the PLC. So this is the Siemens PLC, which is widely used. Okay, you can see this figure that inputs is given and the output is taken from the bottom. Okay, there are some buttons, which has certain features. So what is PLC? PLC, it is actually developed to replace the old relay logic, right? Previously mechanical moving relay logics were used. Okay, but they have very large amount of disadvantages at that time. So to minimize that disadvantages, this PLC has been developed as a replacement of relay logic. Okay, now basically in all the industries PLCs are used. Okay, so PLC is a very important term. PLC is a digital system. Okay, it is a digital system which can store program. In that device we can store a program in the memory. Okay, it has memory, like in the mobile phones we have memory, that in that memory we can store the data. Okay, or memory. It has a number of timers. Okay, timers, counters, specialty modules, input and output modules. Timers mean to give the delay. Okay, to delay any process, like washing machine. If I want to delay my clothing time after 5 minutes, then I can give, with the help of this timer, I can give that delay. Counters mean total number of products produced. Okay, total number of products produced. If in manufacturing plant there is production line of mobile phones, then in one day how many mobiles are produced, who can count that? It will be count by counters. Modules mean the modules mean input modules or output modules. In input modules, how many inputs you can connect. In output modules, how many outputs are you can connect. Then these are actually categorized according to the applications, and we will be seeing PLC in detail, each and every point in detail in our future videos. So you can wait for the PLC. Next one is the HMI. HMI is the human machine interface. So it is kind of a tab, right? You can see actually the layout of the actual plant, how the processing is going on the and you can also control the process with the help of HMI. So HMI is also called as MMI, that is man machine interface. HMI is a control system that provides interface. It provides actually interface between human and machine for controlling. Right? As I've said, it is used for controlling, displaying the online status of the machine, and creating the respective alert signal in audio visual form. Okay, it actually controls, display the status of the device, and create signal in case of any kind of, if any kind of emergency situations occur, if certain machine has been stopped, then you can create with the help of this HMI that the particular machine has stopped. You can give the signal from this device. The HMI consists of the operator panel. Okay, it has an operator panel with the display, control buttons as a touch screen icon. Okay, it is basically in modern there is a touch screen for touching the input and output devices. Audio visual indicating devices is also used. It reads the control parameters from the machine. Okay, control parameters it can read with the help of HMI, interprets that the signal is conditioning block and generate the respective, means it can do automatically the desired work with the help of this device. Okay, now next one is the SCADA, the very important one, SCADA. So basically the SCADA is the main computer, okay, which is actually controlling all the processes. Generally it is referred as the industrial computer. It is or industrial control system, ICS. Okay, that monitors and control. Actually it is used for monitoring and control. On that system we will be able to see operation of all the devices. And okay, the SCADA is so what is the full form of SCADA? SCADA is a supervisory, controlled and data acquisition. Supervisory control. Then what is supervisory control means? We are actually supervising the any process, controlling that process, and data acquisition means we are actually acquiring that data and also controlling that data. Okay, it is a basically it is a software. Okay, basically software which runs on the central PC, means the diagram, the central PC is this. Okay, so this is the central PC in which the SCADA software is installed. On that SCADA software we are actually controlling the devices. It takes the data from different parameters. Okay, it takes the data from different parameter field devices. Okay, and actually it stores the data in the SCADA software. Okay, now the next one is the okay, we will also discuss the SCADA part in the future videos in detail. All this architecture diagram and all the terms MTU, RTU are there in detail. Okay, next one is the DCS, that is distributed control system. It is the customly designed and it is not centrally located. It is actually for custom, means separate or customly designed purpose. Okay, it is not actually designated at a central location like SCADA. Okay, so it is actually a distributed control system. The controller may be different for different applications on the field, that is distributed. Means for any if 2-3 machines are there here and 2-3 machines are here. Okay, at means 3 to 5 locations the machines are at different locations. Then for that different location there is a control system. Okay, for controlling that 2-3-5 machines, each and every devices is controlled with that control system. Then that is called as distributed. The machines are distributed. That for distribution, different control systems are used. That is called as distributed control system. Controller, so it is a control system, right? So controller receive data from field devices. Field devices process on the received data, then it processes that data, and depends on the processing it sends the control, and it also sends the control signals for controlling that particular process. Okay, so this is the DCS. Next one is the drives. Okay, so in automation system, any motion of the mechanical component is controlled by the electric motor. So actually drives mean the motor control, right? In conveyor belt, below that conveyor belts motors are connected. So actually they are moving the conveyor belt. With that conveyor belt all the products are moving also. Okay, so mechanical motion is done by electrical motor, and these motors are drawn by these drives. Okay, these drives are basically AC drives or DC drive, it depends on the situation. Okay, DC drives control the speed and direction of the rotation of the DC motor. Okay, means actually DC motor is controlled by DC drives and AC motors are controlled by AC drive. Then their speed is controlled by DC drive, rotation is controlled by DC drive. And AC, let's suppose a induction motor, it is an AC machine, right? So that induction motor speed, rotation and is all controlled by that AC drive. Okay, so these are the actually industrial devices which are widely used, okay, commonly. So that's all for this video. Okay, I hope you understand with this video. If you have any kind of doubt, you can contact me. Okay, then we will in the next video we will look the applications of this automation devices in medical field, engineering field, aeroplane means aeronautic fields, medical field. Okay, all this we will be I will explain all these applications in detail in the future video. Okay, so thank you for watching.